In this video, I'm going to do Krugman and Wells page 127, number 3. And you can see that I've already started to set up how I'm going to organize the information that's given in this problem. So I have 4 columns, and I'm going to start filling them in. So I have 6 consumers. Each consumer buys one computer game. And then I'm told how much each of them is willing to pay for that computer game. So consumer 1 is willing to pay $40. Consumer 2 is willing to pay $35, and then it goes down in increments of $5. Okay, like so. Now, I'm told in part A that the market price is $29. That means they walk into the store and they find that regardless of how much they are willing to pay, the actual price is $29. So if they are going to pay it, that's the price they're actually going to pay. So now I can start to think about the consumer surplus. Now before I do, I want to just highlight the crucial assumption that our analysis depends on. Our analysis depends on the assumption that our consumers have the ability to pay for these for anything that they would want in that store. And so that, you know, if, say, consumer 4 will only pay $25 for the computer game, that's not because consumer 4 can only afford to pay $25. It's because consumer 4 made this choice, this educated decision, that they only think that the game, you know, is worth to them $25. So it's a reflection of really their preferences and not their income. Once we assume that and adopt this assumption that consumers have the ability to pay, then we can enter into our analysis of consumer surplus and say, okay, well, the consumer surplus is trying to get us to understand what the difference is between what someone is willing to pay and what they actually paid. So it's the difference between these two. And so if we want to calculate the consumer surplus for each consumer, what we need to do is to come across and list here in this column the difference between willingness to pay and actually paid. For the first consumer, that'll be $11, meaning consumer 1 was willing to pay $40 for a computer game. They went to the store and found it actually priced for $29. So they brought it to the register and actually paid $29. The consumer surplus, or how much more they would have been willing to pay for that game, is $11. And I'll go down the line and calculate that for each consumer. Now, once we get to consumer 4, you should notice that we're actually not going to make a sale here because the max that consumer 4 is willing to spend is $25. And the price is $29. So consumer 4 is actually just not even going to buy. Neither is consumer 5, nor consumer 6. So when we want to get the total consumer surplus, what we need to do is sum all of the individual surpluses. So we have $11 plus 6 plus 1, which gives us a total consumer surplus of $18. Now, this is doing the problem algebraically, but we can also do it graphically. So let me set myself up for that. Okay, so I set myself up to show this graphically. I have 2 axes. On the x-axis, I will plot the quantity of computer games sold, and it will help if we think about each computer game being held by a consumer. That will help us sort of visualize what it is that we're doing here. And then we have price on the y. So let me start with price. I think that I'm going to plot this and start with 5 and go up in increments of 5. Okay, 35 and 40. And then my quantity, well, I can only have a maximum of 6 computer games sold because I only have 6 consumers and each one is buying 1 computer game. Okay, so now, you know, let's consider consumer 1 and let's think about the max the consumer one is willing to pay? Well, we know the consumer one is willing to pay $40. So that's consumer one. Let's consider consumer two purchasing the second computer game. Consumer two purchasing the second computer game will pay a maximum of $35. Okay, so you can just think about this as a bar graph, and you could think about sort of the right end signifying, you know, the number of total consumers we have, or the number of computer games that are sold. And the height of each bar is just going to tell me the max that they're willing to pay. So let's think about now consumer three. Consumer three is willing to pay a max of $30. Okay. Consumer four is willing to pay $25. Okay, so I just went ahead and graphed all of those bars. Okay, so now we have that the market price actually paid is $29. So I'm going to say that that's about right here. Okay, I really wanted to make that in a, okay, there we go. And so we're going to consider the consumer surplus. Well, the consumer surplus is really just going to be the amount over which some of the consumers would have paid. So over the market price that some consumers would have made. And if I had to show this to you on this graph, it would be the area above the line in each one of these bars. So if I'm going to calculate that consumer surplus, I need to calculate the area in each one of those, in the shaded area. So let me go ahead and do that. Well, I have that here the length of the first bar is 1, and that the height is 10. So this is just going to have an area of 10. In the second bar, I have that again, we have a length of 1, but this one is from 29 to 35. So this is 6. And then I have here again a length of 1 and a height of 1, so this is just going to be 1. And whoops, I did one wrong. This is actually an 11 because it started from 29. I thought it started from 30. It looked like it started. Okay, so 11, 16, and 1. So when we add up these areas together, 11 plus 6 plus 1, what do we get? We get 18. And that was the sum of what we got when we did this algebraically. 11 plus 6 plus 1, $18. Okay, in part B, we're told that the market price decreases to $19. So that means that when they go to the register, actually now, each one of these individuals who want to buy a computer game will actually pay $19. And now we are going to calculate consumer surplus again. And again, we need to adopt the assumption that consumers have the ability to pay, so that their purchases reflect their preferences and not what they can afford. That allows us to think about consumer surplus, which is actually the willingness to pay minus the actual payment. So when we calculate, we just come across and we say, okay, well, what is 40 minus 19? 21. What is 35 minus 19? We have 16. What is 30 minus 19? 11. 25 minus 19? 6. 20 minus 19? 1. And then notice that actually consumer 6 is not going to be purchasing a computer game at all because it costs $19 and they're only willing to pay $15. Okay, so now let's consider the total consumer surplus, just the sum of all the individual surpluses. And so we have 21 plus 16 plus 11 plus 6 plus 1, and that gives us a total of 55. Okay. So that is the consumer surplus if the actual price paid is 19. That is, if you take the amount paid for all of the computer games, like this total at the end of the day, the cash register, says the total sales, and it's 55. It's 19 times 6, 100. Anyway, so 19 times 6, and then 104. So then we have then the $55 is how much more they could have made that day if everybody who paid for a computer game had actually paid up to what they were willing to pay. Okay, so that's the idea of the consumer surplus. Now we can show this graphically. So let's just create some room to show this graphically. Okay, so I just set up my graph here now, and I took the liberty of going ahead and setting everything up because I assume that you now know why I'm setting it up in this way from part A. And so I've set this all up, and so each one of these bars represents, what you could think of a consumer holding a computer game. So it's the max that would be paid for that computer game. So this is, consumer 1 buying one game at a max of 40, and then the second consumer would buy another game at a max of 35, and then the third consumer would buy one computer game at a max of 30. And so, that just gives you the sense of sort of how the information is represented graphically from our table. Now it says that the market price is $19. So now what we did, we're going to do the same thing that we did last time, which is to take a line and just carry it across and just say this is our market price. And then we will represent, remember what consumer surplus is. We're trying to understand how much more consumers would have paid. Now, when we see this sort of this horizontal line at $19, what represents how much more each consumer would have paid is that portion of the bar graph above that line. And I know your book does it a little bit differently. They kind of set the squares out so that they are, they are horizontal as opposed to vertical. The bars are horizontal as opposed to vertical. But I don't really like to do it that way because I don't think it's very intuitive. I think it's more intuitive to do it this way. I hope you don't disagree. So then from here, my consumer surplus is going to be the area that's shaded in each one of these bars. So here I have, a length of 1 for the first bar and a height of, what is this, 19? Yes. Okay. And then I have a height, a length of 1 and a height of, it looks like 15, 16. Okay. And then 1 and a height of, 19 to 30, so 11. 19 to 25, so I'm 6. And then, what is this, to 20, so this is 1. Okay, so when I say, for instance, that this is 1, what I mean is this height is 1. When I say this area of this bar, shaded portion of this bar is 6, I mean that this height right here is 6. When I say that the area of this rectangle shaded portion of the bar is 11, I mean that this height is 11. Now, I'm going with the height because each one of these widths is 1. So I do 11 times 1, 6 times 1, 1 times 1. That's how I'm getting that. Okay, so now to get the total consumer surplus, I need to just add all of these numbers up. Actually, I'm already noticing a mistake. Whoops. That's 21. Okay, so total consumer surplus, I have 21 plus 16 plus 11 plus 6 plus 1 is equal to, And I am going to get the same exact thing I got before, 55. Okay, and notice this matches the sum of all of these numbers, 55. So, same thing. Okay, so I set myself all up for part C. Let me fix that. Okay, and part C says what's the difference in the individual consumer surplus when the market price moves from 29 down to 19. Well, so the first way we can do this algebraically, I've just here in the third and fourth column, I've set up the consumer surplus at a market price of $19 and at 29 and set them next to each other. And then in this fifth column, I've just put the difference of the two, and so I'll fill that in right now. So the difference just being, the 21 minus 11 being 10, and then 16 minus 6 being 10, 11 minus 1 being 10. This we have nothing to subtract from, so it stays 6. This one, same. And then there's no consumer surplus for consumer 6 at either market price. So that the total consumer surplus, so let's just go down here and just put total at $19 was 55. Oops, 55. At 29 it was 18, and so that the difference between them is 37. Okay, so that's the difference that we have, and that's doing it algebraically. But how can we do this graphically? So let's first draw our, let's draw our two lines. So we have a market price at $29. Oops, that's not what I wanted to do. I wanted to draw an actual line, and I wanted to make it purple. Okay, so 29. And then we had another, it dropped to 19. Okay, so now the difference between the two is actually just going to be the area between those two lines. So this here. Okay. Now, why is that the case? Well, for the first line, the market price of 29, we have that the consumer surplus is just everything above that line. For this second one, when the price drops to 19, again, we have that the consumer surplus is everything above this line. The difference between the two of them is going to be where one area appears and the other one doesn't. And that's going to be in this section right here. So I need to calculate the areas of this shaded area in each one of these 5 bars. So for the first one, this is the difference between 19 and 29, and it's a width of 1. So we have that this area is 10, okay, because this is 1 and this is 10. Same here, same here. Here I have up to 25, and this is 19, so this is 6. And then this here I have up to 20, and from 19 to 20. So this is 1, and this is 1, so this area is 1. So now I add up the areas of the shaded regions inside those two lines, or between them, and I have 10 plus 10 plus 10 plus 6 plus 1, or 37, which matches the number we got when we did it algebraically.